This lesson is on adding and subtracting rational expressions. So when we're working with adding and subtracting rational expressions, we think very similarly to adding and subtracting fractions. The rules for adding rational expressions, so the rules for adding them, are the same as adding fractions, where you're finding common denominators. So if you look at our example right here, it says if A, B, and C represent polynomials, C cannot be 0. We have here A over C plus B over C. When we're adding this, notice we have common denominator, which is C. And so we can add our numerators, so it's A plus B over C. So make sure in the notes you're writing down this rule, explanation, and then the chart. So let's practice adding with rational numbers here. So our first example, we have n over 2n plus 3n over 2n. So we first look at the denominators. We have 2n and 2n, and we say, are these like denominators? In this situation, it is. So what we're going to do is we're going to add the numerators, and since we have common denominators, it's going to stay as 2n. So what I have here is n plus 3n is going to give me 4n over 2n. Now we look and see, can we simplify this down? Well, they both have an n. When they both have one n here, the n's are going to cancel out. And then can we simplify down 4 divided by 2? And we can, which is going to give me an answer of 2 here for A. So this is going to be my answer when we add these rational expressions. Looking at B, we have here 3y squared over y plus 1. Plus 3y over y plus 1. Again, we're going to look at the denominators, and we're going to say, do we have common denominators here? In this situation, again, we do. So we're just going to add our numerators. So when I add my numerator here, we have 3y squared plus plus 3y. So what this is going to become is 3y squared plus 3y over y plus 1. Then what I'm going to do is I'm going to look at my numerator here, my 3y squared plus 3y, and I'm going to see if there's anything in common that I can pull out. And there is. They both have a 3y here. So what I can do is I can pull out a 3y from my numerator. And when I pull out a 3y, what I end up with is y. I pulled out a 3y here, so it's going to be y plus 1. Over my denominator, which is y plus 1. And then we look and see, well, can anything cancel out here? And the y plus 1s can. So my final answer for B here is just going to be 3y. So after you find your common denominator and you add your numerators, you see if there's anything in common you can factor out, and then see if you can simplify it down further from that. So now what we're going to do is we're going to be subtracting rational expressions with like denominators. And something we need to remember is we're going to add the opposite of each term to the second numerator. So let's look at these examples and practice this. So for A, we have 5a plus 2 over a squared minus 4 minus 2a minus 4 over a squared minus 4. So my first step here is I am going to, for my numerator, we're going to distribute the negative to each situation. But before we do that, I forgot to mention that we need to first look at my denominators to make sure they are the same. And we have a squared minus 4 for both. So since we have common denominators, we can go ahead now and subtract this here. So as it's showing here, we're going to distribute this negative to the 2a minus 4. So what I have here is 5a plus 2, distributing this negative to the 2a minus 4, which is all over a squared minus 4. When you distribute that, what you end up with is 5a plus 2 minus 2a plus 4 over a squared minus 4. So now what we're going to do is we're going to simplify this down even further. And so what we get here is we're going to add like terms. So we have our 5a and negative 2a, which becomes 3a. and 2 plus 4 is going to give me 6. So I have 3a plus 6 over a squared minus 4. Now what we're going to do is we're going to factor out the numerator and the denominator. So what do we have in common with 3a plus 6? Well, we can pull out a 3 for my numerator. So what I'm left with is a plus 2. And then I look at my denominator, a squared minus 4. Well, what can I factor out of a squared minus 4? Well, that's going to become a minus 2 and a plus 2. So now I look at my numerator and denominator, and I see if I can cancel anything out here, and I can cancel out my a plus 2. So my final answer for a here is going to be 3 over a minus 2, and that'll be your final answer for a. Let's look at b here. We have 2b plus 14 over b squared plus 3b minus 4, and then we're subtracting a negative 2b plus 2 over b squared plus 3b minus 4 from that. Let's look at our denominators to determine if they're the same, and they are. We have b squared plus 3b minus 4 for each. So we can now subtract this. So in order to subtract, we're going to take the negative sign and we're going to distribute it to each situation. So what we're going to end up with here is 2b plus 14 plus negative times negative 2b becomes a positive 2b. Negative times positive becomes a negative 2 all over my denominator, which is b squared plus 3b minus 4. Once I've done that, then what I can do is I can combine like terms for my numerator, which is going to be this 2b and 2b and the 14 and negative 2. So when I simplify that, it gets we get 4b plus 12 over b squared plus 3b minus 4. So now what we're going to do is we're going to factor out the numerator and the denominator, and if we have anything in common, we're going to cancel that. So what do we have in common with our numerator, 4b and 12? Well, we can pull out here a 4 for my numerator. So what I'm left with is now we have b plus 3, so it's going to be 4 parentheses b plus 3. The denominator, we're going to factor out the denominator. So we think what times what is going to give me b squared? Well, b times b is going to give me b squared. And then I have a positive and then a negative. So my signs for in this is going to be a positive and a negative. And then we think, what are factors that would give me negative 4 but then would add to give me positive 3? It's going to be b plus 4, and then it's going to be b minus 1. So I have factored out, pulled out a common factor for this and factored this out. So now I look at my numerator and denominator to see if I can cancel anything with the numerator denominator here. And in this situation, I can't. So this is going to be my final answer. 4 parentheses b plus 3 over b plus 4, b minus 1. And that'll be it. So let's keep going on. I have a few more examples here. The next example, we're getting into finding the least common multiple. So we've all worked with least common multiples before. And as with fractions, rational expressions need to have a common denominator before they can be added or subtracted, as you know. So if they do not have a common denominator, then what you're working with is the least common multiple of denominators so that we can have a common denominator here. So for these examples, we're going to find the least common multiple. The first example here, we have 5f squared times h and 15f times h squared. So with these two separate situations, we are going to find the least common multiple. So how I go about solving this is we are actually going to be working with the prime factorization. So remember, with prime factorization, we're just breaking apart each situation. So we have 5f squared times h. What makes 5 times f squared times h? Well, that's 5 times f times h. Remember, prime factorization is breaking, it's like factor trees, working with prime numbers, breaking it down to the number 1 and itself, and then breaking apart the variables here. So this is my prime factorization for 5f squared times h. Now I need to find the prime factorization for 15f times h squared. So that's going to be 3 times 5 times f times h times h. So with these two situations broken down using prime factorization, we now can find our least common multiple. And our least common multiple is going to be 3 times 5 times f times h, which becomes 15f squared times h squared. And this will be my final answer. That would be the least common multiple given these two situations. For B right here, again, we're going to be finding our prime factorization, factoring out here actually in this example for B. What we have is x squared minus 4x minus 12, and then we have x minus 6 and x plus 5. So let's break the first situation apart, x squared minus 4x minus 12. That becomes x minus 6 and x plus 2, and we factor that out. And then for our x minus 6 and x plus 5, we just can pull that out again. So what would be my least common multiple for this? We're going to have each of these situations, x minus 6, x plus 5, and x plus 2. And this will be my least common multiple given these polynomials right here. And that'll be my answer. There are a few steps. What we're doing now is we're looking at adding and subtracting rational expressions, and we're taking what we've learned from at this point with finding common denominators, maybe finding the least common multiple, and using all of what we've heard from so far in this presentation, combining it together to add or subtract rational expressions. So first thing we need to think about is the least common multiple of the denominators of fractions or rational expressions are called least common denominators. And we're going to use this method when we're adding or subtracting rational expressions. Here in this chart, it shows us the steps we're going to follow when we're adding and subtracting the rational expressions. So my first step is we're going to identify the least common denominator, or that least common multiple we just found. Our second step is we're going to then multiply the expression by the appropriate form of 1 so that each term has a least common denominator. Step 3, we're going to write the expression using the least common denominator. We're then going to add or subtract the numerators and combine like terms as needed. We then will factor and then simplify from there as needed. So let's go through an example showing you these steps when we're adding and subtracting rational expressions.